Assalamu alaikum students. Now we have to start dimension analysis. This very topic is going to continue for 3 4 days, and it is very much important in respect of entrance examination as well as for the 11th class. Dimensional analysis is very much important because for every physical quantity, by every physical quantity, pressure, volume, temperature, luminous intensity, velocity, acceleration, force, mass, whatsoever may be the quantities, you have to see what are their dimensions. So, in this very dimension analysis, first we should know what is a dimension, what we have to understand from a dimension. As we are aware, we are having the basic or fundamental quantities. Those include mass, length, temperature, luminous intensity, electric current, and quantity of substance. And we those are called as the fundamental and basic quantities. Then we are having the derived quantities. You can say velocity, you can say acceleration. Those are what? Derived quantities. You can say torque, you can say volume. That's a derived quantity. So all those very quantities which are derived, as you have learned from last lesson, which are derived from the base quantities or the fundamental quantities, are called as the derived quantity. Now what is the dimension? A dimension simply means how many times, right? The number of times, I will write it down, the number of times a fundamental fundamental quantity is contained in a given derived physical quantity. So simply the number of times, that is how many times a fundamental quantity is contained in a given derived quantity. Like I will say, you might have heard about, I will place a simple, you might have heard about area. What is area? Area, you say it is length multiplied by length. Actually, it is length multiplied by breadth, but breadth is also a length. So length multiplied by length. When length is multiplied two times, you know that is length into breadth, but breadth is also length. So you will say for length we are going to use dimension here like this, L, then in the brackets, and multiplied by, here we are having again the L. So it is L raised power 1, L raised power 1. Base are same, power shall be added. So we will say L raised power 2. Or I will say for area where having dimension, there is no dimension in mass. So zero dimension. There is no mass contained in the length. There is mass. Once I will say the length of this very pen. The pen is having mass, but I'm saying once we are dealing with the area doesn't have to do with the mass. So we are dependent upon the length. So it is having, in mass it is having a zero dimension, as there is no mass, so zero dimension. In length it is having two dimensions, and in what I mean to say time, it is again having zero dimension. The area has nothing to do with the time. I can place all the three, all the respective seven quantities as I have placed seven, but that will be an ambiguous thing. That will be ambiguity in the paper as well as in answer book. So you have to write it always like in these very three quantities. If there is current, then you have to use the dimension of current. For example, current, you are going to say by if somewhere you are using the current, which is I, you have to use a dimension of A for current. If you are having amount of substance, amount of substance, it will be having a dimension of mole, so on and so forth. So we are having area is length into length. So length I will place by L, another length by L, it's L raised power 2, or I will say there is zero dimension of mass in area, there is two dimensions of length in area, as we are having one length another length, and there is zero dimension of time. So in area mass is not considered, so area has zero dimension in mass, length occurs twice in area, and area is independent upon the time. So now if I will take volume, let me have another physical quantity, that is volume of a substance. Volume is length multiplied by breadth multiplied by height. But if you are going to see broadly, length, breadth, height, all the three are lengths. So it is length, I will place a dimension L there. It is breadth, I will place again a dimension L there. It is height, I will again place a dimension L there. So what it is having the total dimension? Either the volume is having L, 3 dimension, or you will say like this, it is having 0 dimension in mass, 3 dimensions in length, and 0 dimension time. Then place the brackets like this. Is it okay? So in dimensional analysis, as we are having temperature, luminous intensity, electric current, and quantity of matter, I told you they are, whether they are expressed in SI units, or whether any physical quantity is expressed in SI units or CGS units, but the dimensions are not going to change. Whether you will say, if area, if you are taking, I will show it out here. If you are going to say area, it is unit is meter, then you will place what? Meter square. Or if in centimeter, it will be centimeter square. So in meter is length, so raised power 2. Centimeter, that is length. Or if in kilometer raised power 2. So whatever may be the units, it doesn't have to do anything with the units, whether in SI system, CGS system, FPS system, the powers, the dimensions will be same. From the dimensions I can calculate the its units, and from units I can vice versa calculate its dimensional formula. So the dimensions of physical quantity are the powers to which, so I will say like this, dimension means how many times. So I will place now another formula here, another definition here. As now in volume we are having length 3 times. So how many times? The number of times, as I told earlier, the number of times a fundamental quantity is contained, as here the number of times a fundamental quantity is contained in a given derived physical quantity is known as dimension. Or I will say like now this, the dimensions of physical quantity, these are the powers, dimensions, and are the powers to which to which the fundamental quantities are to be raised. So we raise here length 3 times, that is the volume is having 3 dimensions in length, 0 dimension in mass, and 0 dimension in time. So this is one of the lectures that we have completed today. I'll be with another lecture. Till then, Allah Hafiz.